Welcome to EDU World Space.
So, 24.38, sort of the same setup as in 24.28, where we're looking at this line of charge and point P1, trying to find some things out about it. In particular, we want the potential there in terms of this distance d. Then we want to find the x component of the electric field here. We want to say what the direction is. We want to evaluate it to get its magnitude with d equals 6.2 centimeters. And then we want to use the symmetry to figure out what E sub y, the y component, has to be. So in problem 28, we found that you get this form for the potential. It's a natural logarithm. And so if we put in x for d, at x equals d, put in d for x rather, sorry. And putting in the rest of the numbers, just because we'll need that later. You get 2.9 times 10 to the negative third volts times the logarithm of 1 plus 0.135 meters divided by d. So if we go back to this and put in, all right, if we go back to this expression in terms of x, then this is the negative of the derivative with respect to x. And so this will be negative q over 4 pi epsilon naught x times x minus L. And then again, putting our numbers in, because we'll need this momentarily. The magnitude of the x component is 3.92 times 10 to the negative fourth Newton meters, Newton meters. I mean, it could also be meter newtons, but that's not really idiomatic. Squared, meters squared, divided by x times x plus 0.135 meters. Good. So now for part C, since the actual value of the component, not just its magnitude, is less than 0, its direction is in negative I hat. So putting in our 6.2 centimeters for d, the magnitude of this, you just take the expression from here, put in the number that you want for d, and this evaluates to 0.0321 volts per meter. And so the last part here, what is E sub y? If we go back and look at the picture, this is, if we like flip this around, if we send y to negative y, basically, imagine like rotating this around 180 degrees around the x-axis would be one way to do it. Nothing changes. And so if you change the direction of something and it doesn't change, it has to be 0. So basically, since there's no asymmetry in y with respect to here, then the electric field at this point can't have any y component.